Okay, so I think we can start. Hello, everybody. Thank you all for coming to this talk. Um, the, uh, this topic is about .NET Core. And really, what I'm trying to do with this session is to give you a glimpse about how .NET Core is operating a bit behind the scenes, and how you as .NET developers that worked with the full .NET framework can use the skills that you have and the practices that you gained over the years, and how you can transform them into working with .NET Core. So a few years back, Microsoft presented this slide showing and declaring its love to Linux. And the entire Microsoft community was kind of skeptic about what the real meaning of this slide and this sentence. Because for many years, some of us felt like the .NET community was a bit neglected behind and wasn't really sure what is going to be in the next future. Some of you or others might have even switched to another technologies. And so this slide actually marked the new beginning for Microsoft, and it's a good sign for us as developers to make sure that the things that we know and love in the .NET framework are going to stay. And the key point to this slide is what we know as .NET Core. So, my name is Tamir DRESHER. I'm coming from Israel. I'm the chief architect of a company called CLARIZEN. I've been a consultant for many years. I just recently switched to be a chief architect at the company. And so I had a chance to work with a lot of industries, a lot of community companies, and see a lot of projects with the .NET system. I work also as a lecturer at the European Academic Center, and I have two books that I've wrote. Go buy them, it gives me money. So CLARIZEN, just in a sentence, is a SaaS company. We provide a tool for project and work collaboration. We are considered leaders in that field for big enterprises and small companies as well, in every aspect of project management from financial planning and resource planning and so on. Okay, so the agenda for today is first, me explaining what is exactly .NET Core. If someone hasn't been around for a few months and haven't seen .NET Core, I'm going to show what it is. And I'm going to talk about the core components that built it and how they relate to one another and how they interact. I'm going to discuss about the way you can deploy .NET Core applications. And at the end, if time permits, I'm going to talk about .NET Standard as the way to create reusable and shared libraries that you can use in any of the .NET technologies. So first, what is .NET Core really? So .NET Core is a new implementation of .NET. Some of the things that were built before the .NET Core has been adopted in .NET Core, but many of the core components have been completely rewritten. New things, new technologies, and new libraries has been written from scratch. And .NET Core by itself is a new implementation of .NET. This gives a lot of benefits for us because there are a few pain points in the full .NET framework that been overcome in .NET Core. A lot of things about performance are now implemented in .NET Core, and just by switching a simple application you wrote in full .NET into .NET Core, you will get a real gain in performance. .NET Core is cross-platform and cross-devices. The whole purpose of .NET Core is allow us to write a program once and run it anywhere. And this can be on Windows machines, it can be on Linux machine, Mac, and it can be devices like IoT devices, mobile devices, and so on. A really nice feature of .NET Core that unlike the full .NET, when you had an installation on your machine of the full .NET and all the application on that machine share this installation, with .NET Core, each one of your application can have the .NET Core as part of it. And so it allows us to have a side-by-side execution. And if something worked at one time and embedded this .NET Core runtime into it, then it will keep running the very same way, no matter where you're going to deploy it and when you're going to run it, because it doesn't have the effect of being affected by changes you make in the installation of the .NET framework on the machine itself. .NET Core is really modular. Since it was being rewritten, it was also restructured. A lot of the libraries have been isolated and encapsulated as their own modules. And so it allows us something that we call the pay-for-play, which means that instead of bringing the entire .NET framework into your application, which carry a lot of weight, you can just pick and choose the specific areas that you need. For example, if I'm only needing the system.io namespace, I just need the I/O utilities, I can just bring that part. And so I can write an application that is much more thinner and leaner and lightweight and deploy it just with what the dependencies it needs. And of course, .NET Core is open source. Everything is on GitHub. You can go, you can look at the code, you can submit issues, and of course, you can submit pull requests and add fixes or new features into the core itself. So this is a huge step for us. Okay, so now we know about .NET Core. What are we going to do with it? To really understand that, I need to compare it. It will be much more easier for me if I compare it to how the day-to-day full .NET development looks like. So in a full .NET application, you have your source code, in this case in C#. This is a simple console write line application. And this code implicitly references an assembly. In this case, it references the .NET framework because it uses the console class. And this means it has a dependency on the mscorelib.dll, right? Because it needs to use the types that are implemented inside. So you run your compiler, in this case by the command line. CSC is the C# compiler. And you get an assembly, which can be a DLL, or it can be an executable. And inside this DLL, you have all this code that you wrote in an IL format. IL is the intermediate language, is a machine-independent language, which means that later on, when I'm going to run it, it will be compiled into the specific machine instructions. Okay, so we have this assembly. Let's say it's an executable, and now we are going to run it. So when we do that, we are creating a new process in the machine we are running on, in the operating system. Now, inside this assembly that you run, there is a small bootstrapper that was inserted when you created this assembly. This is a native code. And the native code do two things. First, is going and loading a special assembly, DLL, called mscore. And the purpose, the goal of this assembly is to go and find what is the best suitable .NET Framework CLR that should be run inside your process. So the mscore looks into the things that are written inside your assembly. It finds that your assembly needs the .NET 4.0 CLR and goes and search for this CLR. Usually, this is installed inside your Windows Microsoft.NET folder. Inside, it finds the specific version, and it takes the CLR DLL and loads it into your process. Once it loaded this correct CLR into your process, it can now start running the services that the CLR provides, specifically the JIT. The JIT is the just-in-time machine, which goes and reads the IL instruction and converts it, compiles it into machine-specific language. Beside the JIT, we have all kinds of other things. We have the loader, known as diffusion, which looked inside the IL and the code that is being compiled from it, and finds that you have a dependency on the console class. It knows that the console class is inside the mscore libDLL, and goes and load this mscore libDLL by specific rule set it has. It looks inside specific folders, it looks inside the execution folder, and it finds the best suitable assembly to load, and the old thing starts rolling. Every time there's a new type, it goes and loads the specific assembly, and so on and so forth. Of course, we have had other services inside the CLR, like the garbage collection, and many, many other things. So this is the traditional full .NET framework style of development and execution. With .NET Core, things are similar but a bit different. So first thing, we need to understand what are the core components we have inside. Let's start with the .NET Core runtime. The runtime is actually the engine that is being executed when we start running our application. The runtime itself is the one that you can look at as the CLR style of things. Usually, when you are on Windows, it will be inside the program files under the .NET folder. You will have a specific shared folder inside with specific versions of the .NET Core runtime. So usually, when we need to have a machine that only needs to execute .NET Core application, we need to install the .NET Core runtime. But for us as developers that need to develop .NET Core application, we need extra tools. For that purpose, we have the .NET Core SDK. And the .NET Core SDK contains the tooling itself, such as the compilers. It contains templates for generating new projects. It has packages that are cached for being more performant. So when we are loading an application, just like in the traditional .NET framework, the MS Core lib was installed and was loaded, with .NET Core SDK, some of the packages I need that contain the implementation for specific parts of the base class libraries are pre-fetched into my machine, so we will have a faster execution. And of course, it has the runtime itself as part of it, the same runtime as I talked before with the .NET Core runtime. And this as well is being installed inside your .NET folder, inside the program files, under the SDK subfolder. So between those two, and also for serving other purposes that we need while we are executing or developing our application, we have the .NET Core CLI. And the CLI itself is the command line utilities, which are better known as the .NET driver. This is the keyword you write inside your command line to execute or to do other compilation, build, and other functions that you need to do with .NET Core applications. And now, the crazy thing about it is that for each one of those components, you have different versions. You have different versioning. So it might be that you have .NET Core Runtime 2.1, and you will have a .NET Core SDK of 2.1.2. Okay, and together with that, we have a .NET Core CLI that can be 3.0, because each one of those are independent. Now, Microsoft are doing a lot of efforts to make it more the same kind of versioning style, so it will be easier. But still, each one of those components is being developed independently, and you can have installations that are different with different versions. So if you want, you can go and download the specific component that you need, and you can start working. So now that you have all those installed on your machine, how does the development lifecycle look now? So we have the same code, the same application as before, console write line that just write hello world to the screen. And now, because we are in .NET Core, we are actually referencing not an assembly. We are referencing the package that describe what is the runtime that we are relying on. So in this case, I'm working with a Microsoft Net Core app. This is a package that if you look into the packages that are installed to your project, the NuGet packages, you will see them as part of those installations. Like before, we need to build our code. So now we are using the .NET driver, the command line function, and we are giving the specific command to do build. .NET build in the folder of the source code will start this compile and build operation. And now we will get another assembly which inside contains the same IL as you know and love, but now you will only get a DLL. Unlike the traditional .NET framework where you can have either an executable or a DLL, you now with .NET Core have only DLLs, because the meaning of execution is changing when you are talking about cross-platform applications. Together with this assembly, you get a few files that are really important. Those files are configuration files that I'm going to cover in just a few slides. And together, all these binary and the files, the JSON files, you have the deployments that you can now use in order to execute your application. So now, going again and looking at our folder, we want to execute this process. To execute this process, because there is no executable, we need to use the .NET runtime. The .NET runtime, again, is exposed to us through the .NET driver, the same command line. So we are typing .NET with the name of the assembly we want to execute. In this case, it's appdll. And this creates the process for us. Now, the .NET driver itself finds the correct runtime that is associated with our application, and I will show you how it does that in just one slide. And based on that, it loads the correct runtime assemblies from the folder, installation folder that is under the program files.net folder that you have on your machine. And then it starts reading the files that we have that was generated, all these JSON files, and the CLR itself is then executed in our process in the very same way. JIT is starting to run, to read the IL, trying to execute it. When do we see a dependency on a specific component, specific class, the loader will go and find this assembly. Only that now we are not going to the MS Core lib. We don't have the full .NET framework. And instead, the core effects, which is the new implementation of the base class libraries and all the .NET framework that we use, is being functioning as packages. So the system needs to find the NuGet package that was installed somewhere on my machine, or we have the assembly in the specific execution folder, and load this specific assembly to start running. So this is how the whole cycle works. And let's look at a demo to show how it looks like for us. So this is an Ubuntu machine that I have on my Windows as part of Linux components. And so I'm inside a folder and I want to create a new project. I can do it with Visual Studio, but for now I'm going to do it from the command line. So I'm typing .NET new, and I want to say what type of project I want. In this case, it's a console application, so I just write console. And this will generate the files of my new .NET Core project for me that you can see right here. We have the program CS. We can look inside to see what we have. It's the simple Hello World application. Okay, so what I want to do now is to build this project. So again, I'm going to type .NET build inside the folder that contains my CS proj. And this will initiate this compilation and build process. And eventually, we have a new file, assembly file, that is being generated in this location. So let's go into this specific location where it's generated it. And now I want to run it. So all I need to do is, again, .NET and give the name of this assembly. Because I did this entire process inside a folder called update conference, the name of my project and therefore the name of my assembly is also update.conf. So update.conf DLL, and you can see it wrote the message on the screen. Nice. Now, because this is a Windows machine and I have the connection between my Windows operating system and this Linux subsystem, I can go now into my Windows machine, okay? This is the command line for Windows. And again, I can go inside into the bin folder. Inside, I have my debug folder, and inside the netcore app folder. This is where the assembly that I generated inside my Linux was placed. You can see it here. Okay, I have my assembly. It's the one that I generated just now. So now I can run it from my Windows machine and just typing .NET and the name of update.conf DLL. And you can see, same assembly. I managed to run it both on Windows and both on Linux. Okay, so let's look again on this .NET driver. So if I just type .NET, you can see there's a few options I can use. A very interesting and powerful option for us is the info. So if I'm doing .NET -- info, it will show me a lot of information that I need. So we can find inside what is the specific versions that I have for each one of the components. So you can see on my machine, I already have a few installation of .NET Core SDK. The latest one is this 2.1.402. And there are bigger versions available right now that you can go and install. But over the years and over the time, I installed a few versions. And so I can pick at any time which specific version I want to use. And also, if I have some application that was developed with 2.1.201 and still wants the dependency on it, it can make it. Now, the new implementation of .NET Core works in a way that if you install a new minor version of .NET Core runtime, automatically the system will take this version, even if you compiled and ran your application before with an older version. But this can be switched off and you can control it. Now, with the .NET Core runtime, I have all kinds of options you can see here. I have a runtime for ASP.NET Core, and I have an option for NetCore app. Now, basically, it's the same thing. The only difference between them is more dependency that were brought beforehand, so it will be faster to load the application and start running it. But in the core itself, it's the very same implementations. Okay. If you have any question at any time, feel free. You don't have to wait to the end. So now, we saw how we can create an application and run it both on Windows and both on Linux. And let's talk a bit about those configuration files that were generated. What is the purpose of those files? So in the full .NET framework, when you are creating your application and have dependency in all kind of other assemblies, basically you have to bring those assemblies into the location where the executable is running in. You can also add a few configuration like probing paths to redirect this loading. But basically, most of the times you'll have those assemblies in the same location as your executable. Now, if we look again inside our inside the bin folder where my binaries are located, and we can see those files. So first of all, let's look at the runtime config. The runtime config is the way that the .NET driver use in order to understand what is the correct runtime that needs to be loaded. Because inside the assembly that was generated when I compiled my application, I have no clue about what specific .NET Core runtime I need to use. So the runtime config is the way that we can instruct the .NET driver and the environment which one of the runtimes I want to use. So specifically, I'm writing here that I want to use .NET Core App 2.1. This is the type of .NET Core that I'm using. And the framework I want to use is Microsoft Net Core App, specifically 2.1, and the 0, because it's a minor, it will always take the latest one. So this is the first thing that the runtime config gives us. Now, if we look at another example, this is a full Visual Studio, and I have an example, another .NET Core application, only that this time, I've added the dependencies to Newtonsoft JSON, okay? This is the dependency, and if you're not familiar with this CSproj format, this is the new format, started with .NET Core, but you can now use it for any type of application. And so I can write my dependencies for NuGet packages inside the CSproj file itself. I no longer need the packages config file. So I have a dependency on Newtonsoft JSON, specifically version 11.0.2. And so when I build now my application and going to the output folder, what we usually expect to see is the .NET is the Newtonsoft JSON DLLs in this specific location, right? This is what you expect to see, because you know that when you start running this application, which has a dependency on the Newtonsoft JSON, and the line for calling to the Newtonsoft JSON classes, it will try to find this assembly and load it. But it doesn't happen here, right? We don't see this Newtonsoft DLLs inside this folder. Now, I can prove it to you that even though it doesn't appear there, let's go to that folder and do the .NET to the name of this is my console app DLL. You can see that it's really using these types. It's really using those classes. I just wrote the name of the type just to make sure the dependency is working. So how come the framework allowed me, how come the runtime allowed me to use this assembly even though it's not there? So the answer to that is those files that we have here, the JSON files. We have the update conf deps JSON, and the whole purpose of this file is to include all the dependencies that my application has on the specific packages and assemblies that I want to use. So in here, you can see that underneath, if we go to the same, let's open it in VS Code as well. So now if we look at this deps JSON, you will see that I have this, this entry over here that specifies that my application needs to use the Newtonsoft JSON in this specific version. Okay, but it still doesn't cover how does the system find this assembly. So it knows that it has the dependency, but where can it find it? And I showed you before we have the runtime config.json. And we also have another file, which is the runtime config dev.json. The only difference between the dev and the runtime config without the dev is that the dev is used in developed machine. And specifically, it includes a runtime config for the additional probing path. By default, with the new NuGet implementation, all the packages that you install on your machine, no matter in which project, will be included inside a folder, a shared folder on your machine. On Windows, it's the user folder under .NuGet packages. So now I have all those packages from all of the projects that I'm developing on my machine in a specific and a single location. And so the runtime config I have here instructs the runtime to include this folder as one of the program paths. So when the application sees that I'm trying to use the Newtonsoft assembly, and it sees that inside the deps, this is a package that should include this assembly. This Newtonsoft JSON DLL is part of the Newtonsoft JSON 11 package. It starts to search for this specific assembly. Based on the dev configuration I have here, it will also search inside the NuGet folder as part of the program path, and it will find this package and load it. So that's wonderful for us, because now my output folder, and I can have a lot of output folders, don't need to include a mass of assemblies just to get started. It will be shared and everything will work correctly. But what happens when I'm production site, when I want to deploy my application? I don't expect the deployment site, the servers that I'm installing my application on, to include these NuGet packages. So we're going to discover and talk about it in a few slides. Okay, so just to recap, when you build your .NET Core application, you will have the assembly or assemblies that are generated as part of your solution. You will have, in this case, PDB for debugging, and we have a few configuration files. The runtime config is where you put runtime configuration, which include which type of runtime you want to use. The deps JSON include the dependencies that you want to use. And you have a specific runtime configuration for development that can include other type of configuration just for development purposes. So speaking about those runtime configuration, some of you might have noticed that a very known file was missing from the solution that I created. When we are creating a traditional .NET Core application, you will usually see the app config or web config, depending on the project, as part of your solution. You can put a lot of things inside the app config. You can have your own app settings, but some of the settings are runtime settings that you can use. For example, if I want to change the mode of my garbage collection, the way to do it is to change a specific setting inside the app config, and then the process will behave differently. In .NET Core, we don't have those config files anymore. So for user-specific settings, the things that you have put inside the app settings, you have a different mechanism now. .NET now contains a full library for configuration management that you can use. But for runtime configuration, what should I do? So the answer is the runtime config. Now, there are two ways you can achieve that. First of all, you can go into your CS project, and many of the settings that you have used and put inside the app config can now be included inside the CS project. For example, if I want to change the garbage collection into server garbage collection, I can just put inside my CS project the server garbage collection with a true. Okay, so this is one way. But what happens if I have my application, I don't want to rebuild it, I just want to change the setting. So this goes into the, again, runtime config file. Now, when I put this inside my CS project, the compiler has generated the runtime config JSON file and included this inside. But I can always go and modify this file by hand and include these new settings. And there are many other settings that you can use. So whenever there's a settings you want to use to change the runtime behavior, you should go to the runtime config JSON and put it inside. And I put a link here. Inside the GitHub repository, there's a file with all this configuration that you can use. Some of them are not documented, and some of them are documented. Another thing you can do, another file that you can use is a file called the global JSON file. Beforehand, I show you how you can define which runtime you want to use inside your application as part of the runtime config. But one of the things that was really painful for some of the developers are that whenever they change something, install the new runtime, automatically, if you haven't changed the configurations in your system, it will go to the newer version. So I had a project about a year ago that was deployed to AWS Lambda. AWS Lambda can run .NET Core applications as part of the Lambda function. And it was working perfectly fine, and at some point it just stopped working. The reason it stopped working is because we installed a new version of .NET Core on the environment. We haven't changed the code, we haven't changed anything. But the application, the compiler, our build server, took the latest one. So if you want to make it explicitly from a specific folder and down which version of the runtime you want to use, which one of the SDKs you want to use, you can put a global JSON file and include the SDK and put inside which of the versions you want to use. And this affects all the folders from that point, all the tree of the folders from that point. Now, to see how it's happening in real time, there is an environment variable you can set called core host trace. You can put a number 1 inside. This will allow you to debug what's happening when the .NET driver is doing whatever it's doing, and how the runtime is doing whatever it's doing. It just print a lot of the traces on the screen. So what you can see here is after I turned on this flag, you can see explicitly how the .NET runtime start to search for this for those files. For example, it looks for the global JSON file from every point from where I started my application, and it goes up to the debug folder, and then to the bin folder, to the new project, to the root folder of this where my application is running in C, the drive in this specific point. So one thing you can do is, if you want to make a practical joke on your friend, put a global JSON on the C folder, and all the project he has will behave really, really weird, okay? But don't tell them I told you to do that. Okay, so let's talk about production and how you can deploy your application. So I showed you that in development time, when I'm building my application, I don't get all the dependencies inside my output folder. Well, it's obvious that for production, I do want all those assemblies together. So there are two types of .NET Core application deployments that we are going to discuss in order for us to understand it. So the first is what we call the framework-dependent deployment. The framework-dependent deployment is the style of programming and development we did with the .NET framework. We are writing our code, we have our assemblies, and we just give those assemblies to put inside the production site. Okay, these have a dependency on the environment, the runtime that you want to use, that should be installed on that machine. Just like I installed the .NET runtime on my machine, and then when I run my application, it searches for that .NET runtime inside my installation folder. So it allows you to just write .NET DLL, app DLL, and it will search for the runtime and run it. So this is simple, this is what we know. Another model, which is called the self-contained deployment, is where you want to take all the dependencies, including the runtime itself, and put it as part of your deployment. Basically, what it does, it goes and take the .NET runtime that you installed on your development machine, it copied it into the output folder, and change the name to the name of your application. So for example, if I have my application called app, and in this case I have app DLL, when I'm running with the self-contained deployment, the .NET driver and the .NET runtime are copied into my output folder, and the .NET exe is renamed into app.exe. And what it do when I run this app.exe, it sees that the name has changed. It knows that it should work as a self-contained deployment. It searches for the app DLL, and it starts from the execution folder itself without going and searching for the runtime in another folder. Now, to do this self-contained deployment, you can do it in various ways. So one way, you can go and put inside your CS proj, inside runtime identifiers, the names, or better known as the runtime identifiers of the specific runtimes. For example, in this case, I have runtimes that I want to use for Win10 x64 and for OS X 10.11. Okay? Which means I'm targeting my application to run on both platforms. Later, when I want to publish my application, I can just go with the .NET driver and use the publish keyword and specifying to which runtime I want to publish to. So what it go and do is going and bringing, and it can take a while for the first time you're doing that because it needs to download all the NuGet packages that should be used. It will go and bring all the files that are needed in order to run it inside the macOS. But then I can take this output folder for macOS and just give it to my macOS users, and it will work perfectly fine. They don't need to install any .NET Core environment or any other thing. So if we go again into this application that I showed you before with the NuGet JSON, with the instance of JSON, so again I can go into the CS proj folder. Okay, this is the folder with my CS proj file and all my code. I can now take this publish command and put it here. It might take a while for it to download all the NuGet packages that it needs in order to work with macOS. But now when I go into my output folder, inside my bin folder, this was released actually. So now I have my .NET Core app output, but inside this output, you can see I have a folder now, and this folder is for OS X 10.11. If I go inside this folder, did I go inside? Yes. So now inside this folder, I have all kind of other new files that are needed in order to run it inside the OS X. Another way you can do it is if you go to the full Visual Studio, okay, you have, if you right-click on your project in the Solution Explorer, you have this publish. And now you can create a publish profile. In the publish profile, you can specify what is the target runtime you want to publish to, okay? And so you can create all kinds of profiles and run them afterwards, and it will do all this fancy stuff that I just showed you, so you can take the output folder and just give it to your users. Now, even if you are not targeting to another platform, even for your own platform, what the publish does, besides bringing the platform-specific assemblies, is also taking all the dependencies for all the other packages that you are using, and they copied it into the output folder. So if I have my Newtonsoft JSON, why didn't it go inside? So if I'm now going into the publish folder that it created for me inside the output folder itself, you can see it copied all the DLLs, all the assemblies that I have dependency on. And we will find somewhere here also the Newtonsoft JSON DLL, because it's a NuGet that I used. But you can see that implicitly I'm using the .NET Framework itself, so all the assemblies that are related for the .NET Framework were also copied into my output folder. So this is what the publish is used for, okay? Okay, so I have 7 minutes to talk about .NET Standard, so let's see how it goes. So, .NET Standard. Now that we have a way to create application that can run on any platform, on any operating system, we want to have a way to create libraries that we can use in each one of those environments. Write once and use anywhere. So let's talk about the problem. In the beginning, right, we have .NET Framework, created all kinds of packages for .NET Framework that relies on the core class library. And now we have .NET Core, and we might have more and more types of .NET versions and environments. For example, Xamarin, that is using Mono as of this moment. So how can we create something that can be used on all of those technologies? So one of the things that we used before, a few years ago, was something called the portable class libraries. Who used portable class libraries? PCLs? Okay, I see a few hands. So the way portable class library worked was by taking the intersection from all those frameworks and then creating a new files that contains only the implementation that can be used by all of them. So for example, if I'm targeting for .NET Framework 4.5 and for Windows 8 and for Silverlight 5, they have only a small area that is intersected that they all can use. And now we have a specific profile. So inside the .NET Framework installation on your machine, you will see a folder called Profile. This is the profile for each one of those combinations. So specifically for the combination I showed you, it was given an identifier. Machine generated this identifier. It's not something that it's easy to really understand what 4.9 means. And inside this folder, you will see all the assemblies that needed in order to run .NET Framework application. Specifically, let's look on MS Core lib. So you will see inside this MS Core lib, it has a lot of type forwarding. The type forwarding attribute is something that you can use as well, which specifically means that a type was once inside this assembly, mscorelib4, but because mscorelib4 was split into other assemblies, you can now say this type has moved, has relocated to another place. Okay? And so this mscorelib assembly has references to the other assemblies. And when we are typing type forward to the new type, which is located in another place, when the application is trying to load the mscorelib and find this type, it sees that it was moved to another place and then loaded from there. Okay, this is how it worked. So the problem is that with every new version of .NET Framework or a .NET system, you had to create new combination. And the amount of profiles that you need to maintain was really, really high. So it was not really scalable. So a better solution is what we call now .NET Standard. And the way it works is different. Instead of taking the intersection, let's define the surface area. Let's define what is the interface that each one of the version of the implementation needs to implement in order to be called .NET Standard. So you can say that no matter which version of .NET you are, if you want to be .NET Standard 1.0, you have to have the system.object type. And therefore, if I'm now using this .standard, if I have a dependency on .NET Standard, I know that it doesn't matter if it's 4.5 or 4.6. If they are saying that they implement .NET Standard, they have this object. So the .NET Standard is kind of an interface you put above the real implementations for each technology. And it works in a way that with every new version of .NET Standard, it includes all of the things that was in the previous version. So let's say .NET Standard 2.0 contains all the things that .NET Standard 1.6 included as well. So I can just upgrade my code and I know what I can use. So the way it works is really, really similar to what we saw. So you can create a new project. Okay, this is in Visual Studio, I'm creating a new .NET Standard class library. I'm specifying the target framework to be .NET Standard. And now, this gives me a dependency on a NuGet package. Inside this NuGet package, if we look inside, we see we have a .NET Standard DLL. But this DLL itself includes only the definition of types. You can see the implementation is empty. So if I'm having my array list type, all the code, all the properties, everything is just return empty or null things. Later on my machine, on the machine I'm trying to run my application on, I have another .NET Standard DLL inside my runtime. And what will happen now is that this runtime, this .NET Standard, also includes all the definition of the types, but it includes type forwarding to the real implementation. So you can see the example in this case, we have .NET Standard 2.0. It's specifying that there is a type forward to array list, and specifically this array list type is in a file that was referenced here in system collection specialized. If we open the specialized assembly, we see that the real implementation sits here. So what happened in runtime is that when I'm developing, I only need to know the definitions. I only need to know that something exists. But when I'm running my application, it finds the forwarding declaration and goes to the real implementation and loads it. This allows me to create new implementation of .NET Framework or any other .NET Core and give the real implementation in a specific file and just change the forwarding. So this is how .NET Standard works. Okay, so I think I made it on time. Okay, so first of all, thank you. What I try to show in this presentation is really what are the core components that you need to know about in order to work with .NET Core. So I talked about the differences between traditional .NET application, full .NET Framework application and .NET Core. What are the runtime, the SDK, and the CLI types. And I showed you the different deployment models that you can use in order to execute it on your machine and on production sites. I talked a bit about .NET Standard, just to give you a glimpse about how it works. So now you can go and create real cross-platform and cross-device application and libraries. So thank you. I don't know if we have time for questions, but I will be in the expert zone, so you can go and talk with me. I will be there for some time now. Okay. Thank you very much.